question 6, if you want to join us there. So what about question 5? What do I know about the exterior angles of a polygon? What number should always come to mind when I say exterior? Interior, you should think n minus 2 times 180. And exterior, you should think what? 360. So interior, I want you to think n minus 2 times 180. Exterior, I want you to think 360. Okay. So if the exterior angle of a polygon is 30, how many sides does it have? 360 divided by the exterior angle is going to give you the number of sides, or 360 divided by the number of sides is going to give you the exterior angle. So what equation do we want for number 5? What do we have that we can replace? I want the n for sure. It says how many sides, so that's what I'm looking for. And I know that the exterior angle is 30 degrees. So if I substitute a 30 degrees in here, what's 360 divided by 30? That's my number of sides. So 360 divided by the exterior angle is going to give you the number of sides. Okay, something to file away on a sticky note in your head. Number 6, if the sum of the measures of the interior angle, so sum of the measures of the interior angle, I think n minus 2 times 180, n minus 2 times 180 is, when I translate that, I set that equals to 1980. How many sides does the polygon have? So if I know the total interior angle measure is this, how do I find the number of sides? How do I work backwards to find n?
Explain it, but instead do the problem backwards.
Absolutely. So if I see multiply by 180, how do I do the problem backwards?
Like minus 2, then divide by 180.
You want to divide by 180 first. Yes. So if you're working that backwards, PEMDAS would tell us to do parentheses and then multiplication and then add and subtract, right? So we're going to do that backwards. We're going to undo the parentheses, right? So we're going to divide by 180. What's 1980 divided by 180?
$11.
11. And then how do I undo that minus 2? Perfect. So then n equals 13. And I can double check that because, you know, I'm sometimes not so sure when I do weird things like that it works. So if I double check it and I pull out my calculator, 13 minus 2 times 180, 13 minus 2 times 180 equals 1980. I know I got it right. That's the one thing about algebra that I much prefer over geometry. You always know you have your right answer in algebra because you can always plug it in and double check, right? We kind of miss that in geometry a little bit. Number 7 is kind of an evil problem. I'll be totally honest. So what I like to do here is I like to separate out the 2 triangles. Think about the 12-13 triangle. And there's a hinge right there. So if I close the 12 and the 13 triangle, what's the smallest thing that I could have for a third side? When we're finding the range of sides, we add and we subtract. So what's 12 minus 13 or 13 minus 12? 1. And then it's got to be bigger than 13, or it has to be smaller than 13 plus 12. So that's 25, right? So this side here can be anywhere between 1 and 25. That's an X, by the way. It's just not very neat. So what about this other triangle, the 5, 18 triangle? If I close that triangle flat, what do I have to do with the 5 and the 18? Absolutely. So we'll do 18 plus 5 and 18 minus 5, and we get 13, question mark. Did I do that right? Yeah. And 23? Yeah. 13 and 23. So if the green triangle is by itself, we can have all the numbers between 1 and 25. And if the blue triangle is by itself, we can have everything between 13 and 23. But if they're attached, right? So pretend they're attached, they're going to get stuck. So the blue triangle will only close to 13. It won't go any further. So I'm going to take my bigger number between these two. I'm not going to use the 1. I'm going to use the 13. And then between the 23 and the 25, it's not going to open all the way to 25 because it's going to get stuck at 23. So we need to use, we've got 4 numbers here. We need the 2 in-between numbers, if that makes sense. So if you had them on a number line, you'd have 1 and 13 and 23 and 25. You want the in-between numbers. Everything in the middle. But you can't have the 13 and you can't have the 23 because that's going to make it go flat. So when we start choosing numbers down here, we want the 15 and that's it. Because 15 is the only number between 13 and 23. And that's just a stinky question. But they do come up, so I feel like I got to show them to you. How would you approach 8? Because we didn't spend nearly enough time on these kind of questions. How do we approach 8?
You could do proportions.
We could do proportions. So I love it. You see the word similar and you think proportion. What numbers would I put in the proportion? 20 over 24, because they're in the same triangle. And then I heard 36 over 42, because I need the small number on the top and the big number on the bottom. So do you cross multiply here, or do you divide and get the decimal? Or does it matter?
It doesn't matter.
It doesn't matter. Which one do we want to do? Multiply or divide?
Divide.
Okay. So what is 20 divided by 24?
0.83 and then the
Sweet. And then 36 divided by 42.
0.8.
So do those match? Are those equal to each other, or are they not equal to each other? Not equal. So we've got to say not similar. If they were equal, then we could say side, angle, side, because I've got a side and a vertical angle and a vertical angle, and then another side and another side. So this is either going to be side, angle, side, if the proportion is true, or not similar if it's not true. Questions on that? Did I go too fast? We've covered so much material so far this year. There's just so much to review. Which of the following is a valid conclusion? So the shape is a rectangle. Then it's a rhombus. The shape is a rhombus. Then it's a rectangle. Is that a valid pattern?
No.
It's not. That's converse, which is not valid. So then the next one, a shape is a parallelogram. That's the P. Then it's a quadrilateral. That's a Q. This is a parallelogram. That's a P. So it's a quadrilateral, that's a Q. That's the conditional. Is that a valid pattern?
Yes.
Conditional works. Yes, that is valid. We're getting more and more confident. If it is a quadrilateral, P, then it is not a rectangle or a rhombus. That's Q. The shape is not a quadrilateral, so that's not P. Then the shape is a rectangle or a rhombus, so that's not Q. This is inverse because I inserted the not. Is inverse valid?
No.
Not valid. And then the last one, and these are time-sucking questions too. I'm not much of a fan of reading. I don't like these questions. P and Q, but we got to get good at them. So quadrilateral, then a parallelogram, not a parallelogram, so not Q, and then not a quadrilateral, not P. So I switched and negated. This is contrapositive. Contrapositive, is that valid or no?
Yes.
Yes. So we've got a valid contrapositive and a valid conditional. Remember, converse is not valid and inverse is not valid. So what's the contrapositive statement here? If lines are skew, then they are not coplanar. So we're looking for the contrapositive. We're going to negate and switch. What's our answer choice there?
If lines are not the C word, then they are not skewed. Whatever thing.
This one or this one?
It's that one. C. It's C.
It is C. Why is it C, not A? Exactly. So this one already has the not in it, so I have to take it out. And this one doesn't have the not in it, so I have to stick it in. Nice, ladies. What about 11? Oh my gosh, there's a ton of logic on this. P is y equals mx plus b, and Q is the graph is a line. So what is this if an equation is of the form y equals mx plus b? What is that? Is that P or Q? That's P. Then the graph is a line. That's Q. Then the graph is not a line, so that's not Q. Therefore, what symbol is therefore? The 3 dots, absolutely. 3 E's, 3 dots. The equation is not of the form y equals mx plus b, so that's not P. So we've got P, Q, not Q, therefore not P, contrapositive. So which one is that?
A.
It is A. My eyes have such a hard time looking at things with no loops on the Q's. Which is a valid conclusion that can be drawn from these statements? If a quadrilateral is a rhombus, then it's a parallelogram. Quadrilateral is a parallelogram, then its opposite angles are congruent.
Opposite angles of a rhombus are congruent.
Opposite angles of a rhombus are congruent. I 100% agree. We get rid of the parallelograms, and the rhombus and the congruent angles have to come down. Love it. Feel like that took a second just so that we can kind of play with that, right? So your pieces of paper should go together, and if you stick the brads in through the holes, you should be able to kind of create some of your shapes, right? So you're going to use the thin strips of paper and the brass brads to make quadrilaterals in the slides. You're going to make notes on the characteristics of the sides, the angles, and the diagonals. So does everybody have these? Yes? Like I said, if you don't have to have them. You can just draw them on a piece of paper, but you're going to want to draw them on a piece of paper so you can make the markings. You'll also have them in the Google Slides, so you can mark them there, or you can mark them in your digital notebook. So let me share my screen again, and we'll talk through some of that. So you've got Google Slides right here. I can open the Pear Deck, so it's up to you guys whether it's easier to write on the Google Slides or on the Pear Deck. You also have your digital notebook. So you can go to the link on the digital notebook, and you want to go to pages 9 through 14. So any of these resources are going to be good for you. And if you missed yesterday with interior and exterior angles, or you're just still a little confused on them, there's video notes here for exterior angles and interior angles and the whole deal. I'm trying to get to slide 9. We'll see if I can get there. My computer is not responsive today. Lots of videos from Ms. Kimbrough. They're a fantastic resource. You don't have to use any color in particular. Yeah. So slide 9 on the digital notebook is pretty much the same as this cover slide on your slides. So I guess question number 1 is, do you want me to open this Pear Deck and give you the link, or do you want to just use the Google Slides? You guys want the Pear Deck? It's easy to open. So I find that some people like to write on the Pear Deck and some people like to write on the slides. I think my computer did an update last night and it is not happy. Maybe I just have too many things open at the top. That could be too. So ultimately what you're going to do is you're going to make with your angles, or with your little pieces of paper, you're going to make a square, you're going to make a trapezoid, you're going to make a parallelogram and a rectangle. Wow, this is ridiculously slow today. Now my chat is invisible. There it is. All right. So we're going to kind of come back to this because you have all of this information here, okay, in notes. What I want to do is jump down here and everybody make a square. So you should have 4 colors that are the same. You choose which color you want to do. Oh. I got my chat and then I forgot what I was putting in it. There's the link. So you're going to make your square. And then in the Pear Deck, we're going to mark everything that we can mark. What can we mark in a square?
The angles.
The angles, absolutely. What do we mark the angles with? Little right angles, right? So we know the angles are right. What else do we know about a square? Are the sides congruent? All the sides in a square exactly the same? So we can mark those exactly the same. They are congruent. Are they parallel? Got a right angle here and a right angle here and a right angle here and a right angle here.
They're parallel.
They are. And I marked the parallel with arrows. So you want to make sure you mark the parallel with the arrows, right?
How do you draw them?
So you should be able to draw on the Pear Deck. You won't be able to draw like me on the Google Slides unless you have Screencastify. You want to draw on the Pear Deck. Is the Pear Deck open?
Yes.
So we've got our square, we've got right angles, we've got parallel sides and congruent sides. What about the diagonals? Are the diagonals exactly the same? What do you think? If we put those diagonals in, are they exactly the same?
Yeah.
Yeah, they sure are. They're not only the same, they've been bisected. So all of those pieces are exactly the same, and there's a right angle. So the diagonals are congruent, they're bisected, and they're perpendicular. So you want to have all of those markings, the right angles at the corners, the congruent sides, the parallel sides, and the congruent perpendicular bisecting diagonals. The square is perfect in every way. It's got 4 lines of symmetry. We can fold it a bunch of different ways. Let me know if we're ready to go on to the next shape. The next shape is going to be a rhombus. And again, you don't have to make them, but I think it's good to make them if you have the things.
I'm ready.
You ready? All right, so let's go look at the rhombus. Remember, the rhombus is a square that's been run over by a truck. So we're going to start with a square. So you can build yourself a square. And it starts off with right angles, but it goes and gets run over. So for the sides, they're still congruent. They're still all exactly the same because it started as a square. They're still parallel because when it got run over, it stayed parallel, right? Ooh, I'm throwing things around the house today. So they're parallel and they're congruent, but they no longer have those right angles. So how many acute angles are there?
2.
2. And how many obtuse angles are there?
2.
2. And, ooh, that's where I meant to put that. Those angles are congruent and they happen to be supplementary. So acute plus obtuse is going to equal 180. Because these are alternate interior or same side interior angles. So these angles here are same side interior angles. They're going to add up to 180 degrees. My acute angle and my obtuse angle, or my acute angle and my obtuse angle, because those sides are parallel, are going to add up to 180 degrees. They're same side interior angles. So I've got 2 acute that are congruent and 2 obtuse that are congruent. And 1 acute and 1 obtuse are going to add up to 180 degrees. If I put in some diagonals, I don't know if I can put any diagonals in this, but we're going to try. I've got a long diagonal and then a shorter diagonal. So are the diagonals congruent?
No.
They are not. I've got 1 long one and 1 short one. However, the long one is cut in half and the short one is cut in half. So they're not congruent, but they are bisected. Bisected means they're cut in half. So the short diagonal is cut in half and the long diagonal is cut in half. These original angles, right, interior angles, were supplementary because they were same side. But if you follow this diagonal, the top of the rhombus and the diagonal of the rhombus, and then the other parallel line from the rhombus. So I'm going top of the rhombus, diagonal of the rhombus, and then the bottom of the rhombus. What letter does that form?
A Z.
A Z. That means we have alternate interior angles. So anywhere you can make a Z with a pair of parallel sides and the diagonal, or a pair of parallel sides and the diagonal, you've got some alternate interior angles. So you definitely have some congruent angles here too. So there's a lot of combinations of things that go together when you make these quadrilaterals. And each quadrilateral has slightly different attributes. And that's what makes it such, like I said in the warm-up, time-sucking question, because you got to go through all the possible combinations. And it just is kind of a nightmare, to be honest. Questions about the rhombus? Are we good on the rhombus? So we've got a square with perpendicular, bisected, congruent diagonals. But once it's been run over by a truck, those diagonals are no longer congruent. They're still bisected. They're still perpendicular. They're still 90 degrees. Oh, we forgot to put that in there. I forgot to put that in there. They're still 90 degrees, but they're no longer the same. One of them's short and one of them's long. So square and rhombus. Again, I don't want to rush, but I would like to go on to the rectangle. You ready to go to the rectangle? Okay. Are you guys actually building the shapes? Is it helpful to build the shapes?
Yeah.
Yeah?
Yes.
Good. Sometimes it's just fun to build stuff. I'm going to get 2 long sides, I think, for my rectangle. So I'm going to get 2 really long sides and then 2 kind of short sides to build my rectangle. Remember, opposite sides are congruent, so you're going to have 2 of the same color on each side. It doesn't matter what colors they are. Your colors are a little bit different than mine because I didn't have all of these colors of paper. So once you build your rectangle, you've got two short sides that are congruent. Are they also parallel?
Yes.
They are. And I mark parallel with arrows. So they're congruent and they're parallel. And then I've got another pair of sides that are a little bit longer and they are congruent and parallel. What else do I know about a rectangle? How do I lock that in to make it a rectangle? Not a parallelogram.
The angles are congruent too.
The angles are all congruent. If they're all congruent, they all have to be exactly 90 degrees. So we can put in our little 90-degree angles. And in order to lock that in, we've got to make sure that our diagonals are exactly the same. I think I'm going to have to, I don't know if I can do congruent diagonals. It needs to be shorter than that. I might have chosen one that won't make it. Oh, yes, I can. So when you do right angles, you're going to have congruent diagonals. And my legs were too long, so I had to combine my diagonals. So it kind of looks weird. They don't want to hold. They're not exactly the right length. But the diagonals have to be congruent. All right, so hopefully yours work out better. Sometimes these angle legs don't work out exactly the way you want them to. So these diagonals have to be congruent because those are the supports that are going to make those angles stay right. So the diagonals are definitely congruent. They've also been bisected. So anytime you have right angles, you have bisected diagonals. Do they meet at right angles though? Are the diagonals perpendicular? Are your diagonals perpendicular? Or do you have one obtuse angle and one acute angle? Obtuse and acute? Absolutely. So we've got obtuse angles opposite the long sides, and we've got acute angles opposite the short sides, right? Do we have any alternate interior angles? Can I make that Z anywhere? Got a parallel line and a diagonal and a parallel line. Can I make some alternate interior angles? It's starting to be too much, isn't it? These attributes are no fun. You did these in 7th and 8th grade too. When I taught 7th and 8th grade, it wasn't fun then either. They do kind of make cool pictures though. So we've got our diagonals. Diagonals are congruent. They're not perpendicular. And we've got alternate interior angles. We ready to go to the parallelogram? I'll post the video. So if you're not quite there, there'll be a video where you can get it. And you can always go into the digital notebook and look there too. Okay. So, I just didn't change the words. Push your rectangle over to make a parallelogram. So make a parallelogram. And what can you mark? So I've got my rectangle. Now I need a parallelogram. Parallelograms are going to have two pairs of parallel sides that are congruent, right? Lost my audience. But it's been run over by a truck. So I've got congruent and parallel lines. And congruent and parallel lines. We get kind of tired of doing that. They are congruent, they are parallel. Are the angles congruent? Or do I have one acute and one obtuse?
One acute and one obtuse.
Absolutely. So I've got two acute angles and two obtuse angles. Acute and obtuse. What's an acute plus an obtuse going to add up to be?
180.
Mm-hmm. So acute plus obtuse are going to equal 180, either that way or this way, because they are same side interior, right? If we add some diagonals on there, are we going to have congruent diagonals? Or is one going to be long and one's going to be short? Absolutely. One is going to be long and one is going to be short. Mine aren't working out exactly right. This might be the benefit of the paper. You can just make a new hole if you need it to be longer or shorter. So we're going to have one long diagonal and one short diagonal. They are bisected. So the long diagonal is bisected and the short diagonal is bisected. So they are bisected, but they are not congruent. Do they form alternate interior angles? Can I make that Z?
Yes.
Yeah, absolutely. And I can make it the way I've been making it, or I can make it this way, right? So they can go in multiple directions, but we definitely have alternate interior angles because you can make that Z. Or you can make the Z this way. I want you to try the trapezoids tonight. Okay, so build an isosceles trapezoid. Decide what angles and what sides are congruent, which ones are supplementary, if anything, and then how are the diagonals related, and do you have those alternate interior angles? So remember, for an isosceles trapezoid, you've got one pair of congruent sides. That's why it's isosceles. Okay. And then for the right trapezoid, it's called a right trapezoid because we've got two right angles, a right angle on the top and a right angle on the bottom in this case. I want you to tell me what you see after you build your shape, what else you know about the sides, the angles, and the diagonals. Okay, questions on that? So the two trapezoids for homework tonight.
What time are office hours?
Office hours are 2 to 3 today. Yep. What I'm trying to rush to is this last slide. So the last slide is, I think, the most fun thing to do because it's so cool. If you haven't opened this yet, this is your hologram, okay? So what you're going to try to do is use your protractor, a ruler, or whatever, and on some paper, you're going to draw this trapezoid, okay? You want it to be about 12 millimeters. That's 1.2 centimeters or about an inch. And then 6.15 millimeters or 61.5 millimeters, right, across the bottom, and then about 43 on the side. You're going to try to draw that on a piece of paper. Then you're going to put that lamination plastic on top of it and trace it onto the plastic. Sharpie works the best. I can't afford to give everybody a Sharpie. You don't 100% need the Sharpie, but if you have it, it is very helpful. Now you can either cut these out 4 individual ones and then tape them all together. So I don't know if you can see on my picture. I'll show it again when I stop sharing. This one I cut out 4 separate trapezoids and I taped them all together on the edges. Okay. This one, I did like the one on the right. When I drew it out, I drew them next to each other. And then I just cut out the perimeter of it without cutting on the dotted lines. I folded the dotted lines like we folded the snowflake. And then there's only one place that you need to tape. Okay. So more directions in here. If you go to the link, hopefully the link works. It'll force you to make a copy. So make a copy and it should open. This gives you some directions on how to make it a little in more detail, right? So it gives you all of the measurements again. It gives you a little bit of history on what, like where the whole hologram thing came from. Tupac was the first one to give a hologram concert. This is what it's going to look like on your cell phone. So once you make it and you tape all your edges together, you'll sit the small base on your cell phone and go to the links down here at the bottom. Okay, it gives you a little bit, a chart with some different sizes. So like I have a really big cell phone, not a tiny cell phone. So I wanted to make mine a little bit bigger. So I used 18, 87, and 62. My daughter has a smaller iPhone and she uses this one. And then I have another like Chromebook tablet size and then a laptop size. So you decide what size you want to make it. And then down here at the bottom, you've got some videos. So when you click on this, it'll take you to videos that will work with this. Okay, at least I thought it would. So you're going to go to any of these things. It'll look like there's 4 things dancing around. You put your projector on the top and play the video in a dark room, and all of a sudden you'll have a hologram. Okay. So again, the way it's going to work is on your cell phone, you're going to run one of those programs and you're going to sit your trapezoid base down. So this was my first one. You'll see it doesn't sit perfectly flat because my trapezoids aren't exactly perfect. This one sits a little flatter because I did a little better job of cutting it out. Okay. So I want you to try to do this tonight. See if you can draw the trapezoids onto the plastic and cut them out and make your hologram projector. I want to see them tomorrow. You have to watch the videos in a dark room though. It won't show in a light room. Questions? So quiet. Tomorrow we're going to have a playlist. So holograms, hopefully you can get those done tonight, and your 2 trapezoid pictures with your models. Okay? And I will see you later. That's the end of class, y'all.
Bye.
Bye.
Sierra, did you have questions, sweetie?
Hello guys, this is Inside Beijing. Today, this part is also made of. Go ahead and see how it works. Alright guys, this is close shot of the 3D hologram projection pyramid. So let's massage first. So this is a card. It says,
Morning, guys. How are we? Nobody? How are we today? Good. I woke up in a funky mood today. What, Riley?
This time I posted instead of you. I forgot to turn on my headset.
Can't believe it's the 10th already. Oh my gosh. Feels like it was just Halloween. Kevin, did you get your driver's license? Woohoo! I'm glad to hear DMV is actually seeing people. Morning, Faith. Morning, Rory. Looking to see if I missed anybody. Evan. There's Esther. Braylon, I saw you, right? Yeah. There's Jaquan. So Liam, Josh, Sammy. Liam, Josh, Sammy. So we ready to finish our dream houses today? Evan.
So I just gotta go back in and put in those on. I gotta include every shape.
Yeah, so you need to have at least one example of all 6 shapes. And some of them require some heights. And the height is what is sometimes the hardest part I'm trying to close out all my tabs that I had open for my last class. It's like excessive how many tabs I end up with for their class. Morning, Liam. So I'm opening up yours. And I did put it in a folder, so don't be confused by that. Although I need to change the date on the folder because I put 2 days ago, not yesterday. There we go. So yeah, let's go ahead and start. If you want to meet me in our Schoology page, you want to go to your dream house floor plan. So that's yesterday and today. Hopefully everybody made their blueprint yesterday and labeled everything. So today is going to be calculating. And if I open it up, I don't want to read through all of the directions. My computer's being crazy slow today, by the way. But your floor plan must include distances and measurements, and it must include at least one of each of the shapes on the geometry formula sheet. So you have to have a triangle, you have to have a rectangle, you have to have a parallelogram, a trapezoid, a hexagon, that's a 6-sided shape, and then some kind of circle. A lot of people are using semicircles instead of full circles. That is completely okay. I have one group in another class that's using 3/4 of a circle, which is kind of cool. So you can figure out how to add your circle in wherever you want, but you do need one example from each of these shapes. And I know this becomes a little unrealistic because it's not what houses normally look like that are square and boxy. What we're looking for is like a next level dream home. Okay, so this is definitely going to look a little weird. It does need to be slightly realistic though. So I want to know what rooms each of your things represent. You can put your drawing here. Lots of people are having problems clicking on that. So they just create their own Google Draw, which is perfectly okay. And then as you find the living room, the perimeter and everything, perimeter is pretty straightforward. So if I go back up here, perimeter is just going to be the distance around. So if I know all of these sides, I can find the perimeter pretty easily, right? Perimeter for the circle is just the circumference. So you're going to have to use the radius or the diameter, whichever one you've put in there. Sometimes area is where it gets a little tricky though. So if I've labeled my sides, then somehow I got to figure out what the height is, right? If I've labeled the base in my parallelogram, I got to figure out what the height is. Your height has to be realistic, okay? So kind of think through that. A parallelogram, the height and part of the base form a right triangle. So for perimeter, you're going to want this hypotenuse, but for area, you're going to want the height. Again, same thing for the trapezoid. For perimeter, you're going to want these diagonals. They become the hypotenuse of right triangles. But for the area, you're going to want the height of the shape. Same thing for the triangle. So anywhere there's one of these dotted lines for the height, you've got some kind of right triangle to think about. And you might need to use some Pythagorean theorem at some point to figure that out. The hexagon is similar. The A is like the altitude of this invisible triangle. So remember when we folded our snowflakes, we had all those central angles. So the central angle is kind of where that altitude comes from. It's the height from the center of the shape up to the flat side, okay? So that A is just the height of that 30, 60, 90 triangle right there. And we can talk about that in your groups if you get to a point where you're stuck. But basically, you're going to make your drawing and label it. And I have an example somewhere. Where's my example? I clicked too far out. So I'm going to have to go back in. There's an example in the next assignment that we're going to do tomorrow. So if you want to open this up, you can kind of see what I'm looking for. So what I'm looking for from you, this is my blueprint. It's a little extra. It's got many more than 7 rooms. I think it has 10. But I want to know what it is. So I have this greenhouse because I love plants, but I want to make that my dining room because I like to eat among my plants. I'm going to have a little office. I'm going to have a restroom and a closet off of my bedroom on this side of the house. I'm going to have a home gym that overlooks the pool because I think that would be super cool. We love to watch movies at my house. We're always watching movies. So I want a home theater because, you know, in real life, I'll never have enough money to have that. And then on the other side of the house, I've got another bedroom and a restroom closet. So I've got a semicircle, a triangle, a rectangle, right? I've got all of my pieces. And then my pool out here is another hexagon. But these 2 hexagons are different. So yours doesn't have to be as elaborate as mine, but this is what I'm looking for. Okay. Does that make sense? Questions, comments, concerns, worries? Morning, Evan. All right. Then if there aren't any questions for the whole group, I'll put you back into your breakout rooms and you guys can work on them, work on calculating, work on labeling and all of that. Let me make sure I've got all of my breakout rooms set up. So in 1, I had Daniel and Caitlin and Robert. And in 2, I had Amin and Jaquan and Mikhail. And in 3, I had Esther and Valerie. And in 4, Justin, Lovely, and Rory. Justin, Lovely, and Rory. 5, Evan. Evan, where are you? There you are. Josh. Ooh, Josh isn't here, though. And Riley and William. And Braylon, Brianna, Daniel, and Liam. Kevin, whose group did I have you in? Did I have you with Justin, Lovely, and Rory? Liam and Praline? Okay, I'm going to keep you guys all in there then. Okay. All right, I'm going to open the rooms and I'll see you when you call me in. Daniel, do you guys have questions? Can I help with something?
Oh, my bad. I didn't see the breakdown thing.
You're all good. What? Hey guys, how are we?
Good. Good.
Your floor plan looks fantastic. I want to buy it. What a cool garage.
Thank Caitlin for that.
So the perimeters are going to be pretty straightforward, I think. Let me know if you get stuck on the areas.
All right.
But I think you're good. Is this 6 feet for the pool, the radius, or the diameter?
Diameter?
Okay. So when you're using the formulas, just make sure like you're consistent that the 6 feet is the diameter. Okay. But everything else looks great. Do you have any questions for me? I see the question marks, the blueprint, question. That's what you just drew.
Yeah, that's just what I named it.
Oh, okay. Yeah, it looks fantastic. All right. I'm going to leave you guys to it then. Gentlemen, you have a gift. I love how you put those shapes together. So now maybe somebody can start adding in some text boxes or a chart over on the side to tell me how, like, the dimensions of each of the shape.
Yeah, that's what I'm doing right
Okay. And then what rooms they are.
now. Okay.
But that looks fantastic.
It doesn't even look like a house.
It just doesn't look like any house that you've seen. I think that would be a really cool house. Cool. All right. Let me know once you start, filling in your numbers if you have any questions on how to find the area. Usually the perimeter is pretty straightforward. Okay. Hi, ladies.
Hi.
Your drawing looks great. I love how they're fitting together.
We took inspiration from you. We had it originally circled, but then we got it.
It gives a lot of places for them to connect. Yeah. Okay. Cool. Let me know when you start labeling and calculating area and perimeter and all of that if you have any questions, okay?
Okay.
Cool. Hey guys, how are we?
Good.
I didn't write down yesterday whose slides you were using. Whose layout did you end up liking?
We're using mine.
Okay. Conveniently, I looked at yours first.
Yeah.
Oh, I love it. Nice. So that's 60 feet. Is the master bedroom? Oh, the master's over there. Now I see it. Okay. Brilliant. Then the pool diameter and radius. Perfect. So now we're working on the nice. 1.5 and 1 for the parallelogram. So your height in the bedroom number 1 is going to be a little bit shorter than 1 because the diagonal is 1. The height is going to be shorter than that.
Okay.
So and that's what I was trying to say at the very beginning. For most triangles, the parallelogram and the trapezoid, when you start doing area, you're going to have some kind of height that you're going to need. And that's not always a side length unless you have a right angle. So make sure the heights are shorter than the diagonals on all 3 of those shapes. And since your trapezoid, your bedroom number 1 and your bedroom number 2 are both the same height, like the top and the bottom are parallel, those heights could be the same. So maybe, I don't know, 0.8
Okay.
would be a good one. Other than that, it looks fantastic. And when you guys are finished, just let me know after you figure out the flooring cost, and you can go early whenever you're done.
Okay.
All right. Hey, gentlemen, how's it going?
So far so good. We just labeled all the rooms.
Oh, I like it.
Yep.
And William, I don't think mine is extra. I think yours and mine look very similar. We even have the same shaped pool.
Oh.
Yeah, I like it. So just be careful when you start doing the trapezoid bedroom and the parallelogram bedroom that when you do perimeter, you're going to have those hypotenuses, those diagonal sides. When you do area, you're going to need a shorter height. So the height is always going to be shorter than the diagonal, right?
Yeah.
But other than that, it looks fantastic. Let me know if you have any questions about filling in the tables, but it looks like you've already started on that too.
Yeah.
And got smart about the square. We can just do 4 times the side length. Perfect.
Yep.
And side squared. You don't need me. You got it going. All right. When you're finished for the day. So call me in so I can check it and put the grade in the grade book, and then you guys can leave early. Hey, everybody. How are we? Good. So Kevin, Braylene, and Liam, are you guys all working together? Daniel, Brianna, are you joining them, or are you guys working by yourselves? Okay, so Liam, you're working by yourself? Okay. So I'm just going to quietly peek in on everybody. I won't talk out loud. I'll send you notes. Brianna, I love what you came up with. Once you start putting numbers in there, let me know if you have any questions, okay? And I'll come back.
I'm working by myself. It's not like my text not showing up whenever I'm trying to message you back.
Oh, okay. Yeah, my computer is glitching today. I don't quite know. It did an update yesterday and it made it super slow. I need to take
Yeah,
some.
so
Is it? Maybe it's just the internet today.
I just shared my Google Drive.
Oh, great. Raylene, is the link in the assignment or is it separate? Like it's a separate Google Drive?
I just shared it. I can put the link in the where you're supposed to put the drawing. That'll work.
That would be great. For whatever reason, when I search you in my Google Drive, I can't see it.
Okay, I'll put the link in it.
Okay. I'm going to go chat with Rory and I'll send you a comment on yours, okay?
We
Hey,
have
guys.
a question.
Yeah.
We have a question about the how to calculate the final square footage.
Of the whole place?
No, you said like after we have the
Oh, okay. So you're doing like to put the flooring in?
Yeah.
Right? Okay. So which rooms do you want to put which flooring in? Do you want to do the same flooring over the whole place or do you want to split it up somehow? Like you're not going to put carpet in a pool probably, right?
Yeah.
So what I would do, I'm opening your document. My computer is so crazy slow today. It's making me insane. It's like I'm using the school computer again. That's why I don't use theirs. I wonder if I close this video, if that would help. Okay. So in order to do, like, let's just use the entryway living room for an example. So if the area of that hexagon is, so the final square footage. So because you got 2.6 square feet for the like scale drawing, you need to multiply that by 10 squared in order to get the area. Because like your 3 would be multiplied by 10 and your 2 would be multiplied by 10. So you take that 2.6 and you multiply it by 10 squared. Now I see the question. And you take the 3.19, all of those final answers, just multiply it by 10 squared.
Okay, that makes a lot more sense.
Because it's almost like you're matching units. You've got square feet, so you have to multiply it by square feet in order to make it bigger.
Okay, thank you.
Mm-hmm. And then once you do that column, do you know how to do the next table?
Do we just multiply the cost by the final square footage?
Yeah. So if it's $4 per square feet, it's going to be 4 times whatever that square footage is. Yeah.
Okay.
And then just list the rooms. So whatever rooms you're going to put carpet in, like add those up and then multiply.
Okay.
Okay.
Thank you.
Mm-hmm. Hey guys.
So I have a question.
Mhm.
When we're finding area, if we don't have a height, how do we find the area?
So you either have to calculate the height or you have to estimate the height. So which room are you looking at?
The garage. Right?
Okay, so your garage. Let me see if I can share my screen and we can talk about it. What you want to do to it.
It's a hexagon.
It is a hexagon, yeah.